and welcome to today's lesson. Today we'll be learning how to calculate the upper and lower bounds for aspects of 2D and 3D shapes. So as for area and perimeter, we're going to be finding the upper and lower bounds for them. Here is a retrieval practice. Make sure to pause this video and give yourself at least 5 minutes to complete all these questions. Okay. Okay, I'm going to be moving forward now, so just ensure if you haven't finished, please do pause your video. Right, so here are the answers. Make sure to pause your video and give yourself some time to mark these questions. Okay then, awesome. I'm going to be now moving on to the main bit of this lesson. So, when we're calculating the perimeter or area of a shape, we need to think about, when we're finding upper and lower bounds, which values of length, height, width that we're going to be using. Okay, so the common way to calculate the area of a shape is by multiplying two lengths together. So for example, for a square, so if we want to find the upper bound area of a square, we're going to have to use both the upper length and the upper width. Okay, so it's very simple, as in, if we want a big number, we're going to use the biggest. If we want a lower bound of the number, we're going to use the lower bound of each of those lengths. Okay, now if we wanted to find upper bound perimeter, we're going to be using both the upper bounds for both of those lengths. If we want to find the lower bound perimeter of a shape, we're going to be using the lower bound of each of these lengths to find the lower bound of it. Okay, here are some also really important equations. So I actually took this from the last lesson that's on the YouTube, and I just felt like this is really important to remind ourselves again, okay, as we're going through these equations. Okay, so let's go on to the next part of this lesson. So we're going to start doing some I do, we do questions. So here we have this question here. Find upper and lower bound area of these shapes where the width is correct to one significant figure and the height is correct to the nearest centimeter. Let's see. So if we were multiplying two numbers, we want the biggest overall. So it makes sense for us to use the biggest value of each number. So if we're finding upper bound, we're going to do that. So let's talk through how we're going to do that. So we're first going to have to find upper and lower bound for each of these lengths. So for 30, the upper and lower bound is actually, the upper bound is going to be 35 centimeters. Okay, and the lower bound is going to be 25 centimeters. Okay, so that's the lower bound. And then because the center height is correct to the nearest centimeter, we're going to have to find the upper and lower bound separate for these here. Okay, so that means that our upper bound area is going to be 35 times by 4.5, and that gives us our answer, and our lower bound is going to be 87.5. So I want you to pause the video and give yourself some time to do the we do. Right, so pause the video, give yourself some time to do the we do. Alright, so let's go over the answer. So for 40 centimeters, we're doing it correct to one significant figure. So the value of one significant figure here is in the tens. So we're going to half 10. So that means that the upper bound for 40 centimeters is simply going to be 45, and the lower bound is going to be 35. And then for the next one, it's correct to the nearest 1 centimeter. So it's going to be for 20 centimeters, the upper bound is going to be 20.5, and the lower bound is going to be 19.5. Okay, and then now we're going to use these lengths to calculate the upper and lower bound for each of them. So the upper bound area is simply just going to be equal 922.5, and the lower bound area is going to equal we're going to use the 35 length. Okay, so it's going to be the 35 length multiplied by 19.5. Okay, and that's going to give you the answer of 682.5. So all of these we need to have the units on. Okay, so let's move on to the next part of this lesson. So with this one here, we're going to find the upper and lower bound for the area of these triangles, where the height and the length is correct to the nearest centimetre. Remember, the area for the equation is A times half times B times H, so base times height. So we're going to find the upper and lower bound for both of them. Okay, so they're both being rounded, well, they're both being, both have the same degree of accuracy, which is correct to the nearest centimetres. So that makes it a lot easier for us to do. So we do that. I'm basically going to just multiply both of the upper bound base and heights to find out the upper bound area. And what we end up getting is 14.625 centimetres squared. And then we're going to do the same for the lower bound, using the lower bound lengths. So I want you to do the we do and have a good go at these questions as well. Okay guys, now I'm gonna show you the answers now. So we're gonna use, for the upper bound area, the answer is going to be 20.625 centimetres squared. And for the lower bound area, it's going to be 14.625 centimetres squared. Alright, I am going to be moving on, so make sure to pause the video if you need more time. Alright, so now we want to work out the upper and lower bound of these cubes, okay? And all lengths are to the nearest centimetre. So we're going to find that upper and lower bound for each length. Okay, and when we do that, we're going to multiply the highest upper bound lengths together. And what we end up getting for our upper bound volume is 86.625 and lower bound volume 39.325 centimetres cubed. Alright, so I want you to do the we do, and you're going to have to find out the upper bound for each of these lengths and multiply them together to work out the volume. And then for you to find the lower bound volume, you're going to find the lower bound for each of the lengths nearest to the centimetre. Okay. So, for this one here, the upper bound is going to be 2.5 times by 4.5 times by 6.5, because these are the upper bound of each of these lengths. And what we end up getting for the upper bound volume is 73.125 centimetres cubed. Okay, and for the lower bound, we're going to be using the lower bound for each of these lengths. So the first one's going to be 1.5 times by 3.5 times by 5.5, and our answer ends up being 28.5 0.875 cubic. Okay, cubed. All right, I'm going to be now moving on to the next slide. Okay. So we need to find the upper and lower bound for these volumes all to the nearest centimeters, for these cubes to the nearest centimeters. So when we're working out the volume of a cylinder, in fact, we need to first find out the radius. So what we have now here is from one side to the other side is our diameter, and it measures 12, so our radius is going to be 6. All right, so our radius is actually going to be 6. So radius equals 6. So we need to find that both and our height is 10. So we need to find the upper and lower bound for each of these lengths. So upper bound for this one is 6.5, and the lower bound is 5.5, and for the height, the upper bound is 10.5, and the lower bound is 9.5. We're now going to sub it into this equation and work out what the upper bound and lower bound volume is. Okay, so for us to find out the upper bound volume, we're going to be using these lengths to calculate the upper bound volume, and then to find out the lower bound volume, we're going to be using these lengths here. Okay, so our answer is as followed. Right, I'm just going to rub that out so you can see it better. So our upper bound is going to be 13.93, 1,393.69 centimeters cubed, and our lower bound is going to be 902.82 centimeters cubed. So I want you to have a good go at the next set of questions. Okay. I'm going to go through these questions now. So the answers are, for the upper bound, 327.12, and the lower bound is just going to be 147.26 centimeters cubed. Okay. Okay, let's go on to our next part. So here we have an exam question. I want you to pause the video and have a go at this question, and then I will give an explanation. Okay, I'm going to give the explanation now. So if you want to do this by yourself, make sure to pause the video. Okay. So reading the question, it says that A is correct. 8.3 centimeters is correct to the nearest 3 millimeters. 8.2 centimeters is correct to the nearest millimeter. Calculate the lower bound for C and show all you're working out. Give your answers to 3 significant figures. So first thing, this is ringing alarm bells. This is to the nearest millimeter. So the degree of accuracy is in millimeters, but the length is actually in is actually in centimeters. So I'm going to have to first convert A and B into millimeters. So A equals 53 millimeters, and B equals 82 millimeters. So it says to the nearest millimeter, so we need to find upper and lower bounds for them. So the upper bound A is going to be 53.5 millimeters, and the lower bound is going to be 52.5 millimeters. And then for this one here, upper bound is going to be 82.5 millimeters, and the lower bound is going to be 81.5 millimeters. Well, we need to find out the lower bound, so we're just going to use the lower bound lengths. And I know that because we're doing Pythagoras with this. Okay, this is a Pythagoras question. So when we're square rooting, if you want the biggest number, we want to square root a bigger number. So we're going to want to use the smallest numbers in order to find the smallest possible number for C. And that's what we're going to do. So we're going to set up our equation. So we know that a squared plus b squared equals c squared. So we're going to rearrange it to make c the subject. So a squared plus b squared equals c squared. Square root of a squared plus b squared equals c. Not squared, sorry. Equals c. And now we're going to substitute our lower bound lengths into them. So it's going to be 5.2 squared plus 81.5 squared equals c. And when we do that, what we end up getting on the inside is 9398.5 equals c. And then when we square root it, our c ends up equaling 96.9 in millimeters, and therefore c equals 9.69 in centimeters, and this is to 3 significant figures. Okay, I'm now going to be moving on to the next slide. So here's the independent practice. Make sure to pause the video and give yourself enough time to complete all these questions. I'm now going to be showing the answers, so if you haven't paused your video, please do now. So here are the answers. Make sure to mark your work. Okay, I'm going to be moving on to the next slide now. Here are these questions. Make sure to pause this video and answer these questions. I'm now going to be showing the answers now, so make sure, if you haven't completed these questions, do so now. Okay, well done. You guys have worked so hard during this lesson.